Talk of thunderstorms and lightning. First question is, what are thunderstorms? This is the most biggest question. WMO defines thunderstorms as sudden electric discharges manifested by a flash of light and a rumbling sound. So both lightning and thunder are prerequisites for, say, defining thunderstorm on the ground by an observer, meteorological observer. Here there is one small problem that audibility of thunder by a normal human ear is about 20 kilometers. So around 20 kilometers of an observer, if there is a thunderstorm, the observer can hear it. So what really are thunderstorms? If you see the way the clouds develop, those initial little puffs of cotton that you see in the sky, those are your cumulus clouds. Little mature, they become cumulus congestus. They look like big puffed popcorns. So those are cumulus congestus clouds. And these then mature into cumulonimbus clouds. So most of the weather of thunderstorms, when you see whether it is hail, whether it is lightning, whether it is strong winds, generally come from cumulonimbus clouds. Rains can start from the cumulus congestus stage, and sometimes lightning also, but mostly the major point of a thunderstorm's life is during the cumulonimbus stage when you see the lightning flashes happen. So this is that popcorn-shaped cumulus congestus cloud, which gradually becomes the huge anvil outflow, which becomes the cumulonimbus cloud. If we talk of lightning per se, there is two types of lightning, or rather three. One is cloud-to-cloud lightning. That means what really happens is when a cloud starts to grow, once it crosses the freezing level, charge starts to build up because of the strong motion inside the cloud, the droplet particles, charge buildup starts within the cloud. So because of that, there is charge separation. It is something like you rub your hands together and they get charged. So something like that happens inside a cloud. And closer to the ground, generally the negative charge is is prevailing near the freezing level, and the positive charge by a kind of charge separation mechanism, because there are strong updraft winds. These positively charged particles tend to get to the upper portion of the cloud. Both, when the negative charge will naturally neutralize with a positive charge, either within the cloud or with another cloud. That is one way of lightning discharge. The other is when negative charge or positive charge discharges with respect to the ground. So that is the cloud to ground lightning, which is what we are talking about in terms of disasters. So cloud to ground lightning is pretty much what we are worried about. If we see cloud to cloud lightning, as the cloud starts to grow, the thickness of the cloud above the freezing level increases the fraction of cloud to cloud lightning. So basically, when a cloud starts to grow, that means the beginning stage of the cloud is more dangerous for the cloud to ground lightning, which is what harms the people. Definitely, if you see the lifetime of this kind of effect, it will be only around 30 to 40 minutes. That is a very short period when you have to take precautions. Rest of the time, it is not as frightening. Rain will happen, continue to happen, winds may be there, but cloud to ground lightning will decrease. Generally, in the tropics, if we take average over the tropics, cloud to cloud lightning is 9 times higher than cloud to ground lightning. It is because of the thickness of the cloud. Then you have something known as lightning strikes, which we are talking of. These are not always harmful, because what they do is they help to dissolve unusable nitrogen in water, which then creates a natural fertilizer. So it helps in the formation of nitrates, and that comes down to dissolves in the water rainfall that follows the lightning and comes down to the ground. Lightning also produces ozone, so that is a vital gas for us. Of course, in the troposphere that is harmful, but in the stratosphere helps to shield the earth from the harmful ultraviolet sunlight. If you see the climatology of thunderstorms per se and also lightning, you will see that the pre-monsoon season, or not in the winter season, that is January and February, there is a strong prevalence of thunderstorms over extreme South Peninsula and say extreme Northwest India, Jammu and Kashmir, etc. Corresponding lightning pattern, if you see, it is over this region and to a lesser extent this region. During the pre-monsoon season, this is the region of thunderstorms is maximum over East India and over South Peninsula, extreme South Kerala, and again over Jammu and Kashmir. Lightning also you see simultaneously there is a maximum during March, April, May over Kerala region, over Bengal, and maximum over Assam, Meghalaya region, and then over the hilly terrain of Northeast India. When we come to the monsoon season, you note that this maximum has pretty much vanished, but there is a maximum here and one here. This is total lightning, not separating cloud to cloud lightning or cloud to ground lightning. Winter season, if we see, again, the atmosphere starts to cool down and there is only maximum here. Now, although we are mentioning maxima, their value is not the same. If you see lightning frequency, it increases from March, peaks around May, June, if you take all India figures, July, and by September it starts to decrease. So basically March to September is the lightning period, of which cloud to ground lightning for various reasons is the most important factor during this period of June, July, and maybe August. So how do we go about forecasting of thunderstorms? Our Honorable Secretary had, MOES had talked of mesoscale models. Our DGM sir had also talked of mesoscale models that have come up. Thirupugar sir had also talked about improvements in forecasting. This has all been possible because of a very concerted initiative by the Ministry of Earth Sciences. Various sister organizations of IMD, the Indian Institute of Tropical Meteorology, National Center for Medium Range Weather Forecasting, they have given a lot of products that have been very useful for forecasting of lightning and thunderstorm, other effects of thunderstorms, be it wind gusts or be it lightning per se, or even the aerosol mean dust optical depth. All this information has started to come from 2019. These in the short range forecasting have proved really useful for improving our forecast. If we talk of monitoring of thunderstorms and lightning, we have a huge network of observatories, if you see, and AWS network, Doppler weather radar, satellite, and of course, we also have data from foreign satellites. But again, I'll mention this, that maybe the distance between our observatories is around 100 to 150 kilometers. The scale of a thunderstorm is maybe tens of kilometers. So we miss thunderstorms by the traditional methods of observation. So what is the source? What else can we do then? One is, of course, Doppler weather radars. Our secretary sir just talked about satellites. And the third most important thing is the lightning array network output, which gives the lightning flashes, cloud to cloud lightning, cloud to ground lightning, which is superimposed on lightning radar and satellite lightning, so on satellite and radar data along with animation, and this is proving to be a real breakthrough in lightning forecasting, thunderstorm, and forecasting of other phenomena associated with thunderstorms also. How do we forecast in the medium range scale? This is a procedure we follow every day. It's a 7-step procedure. So we analyze the weather of the past 24 hours. We analyze the current observations. That means we not only see where the rain has happened, where the winds have happened, where lightning has occurred, but also what is the current situation of the weather systems. In the next step, we prepare a kind of what is the status of the weather systems. That is the third step. Fourth step, we take all the models. We have mesoscale models. I just showed you the products. We have global models. We have other coupled model outputs. So those forecasts are all taken into account to see which is given the best possible forecast valid for today, which is picking up the weather systems best for today. And then we finally reach an objective consensus about interpretive models. So then we consider which has generally been proving good in the past few days. That is very important because model forecasts always suffer from each model is not always giving the exact result that we need at the scale that we need. So we need to analyze the products of all the different models that are available to us to see which one has performed better in the last few days, not last few years, but last few days, then which is picking up the present situation best, and then we giving weightage to that, we move ahead to building a forecast. The last step before we actually generate the forecast is a video conference we organize with all the meteorological centers so that we are all in the same picture. So this is a daily phenomenon from 10:30 to 11:30 when we sit together and we discuss what we have arrived at as a consensus, and they have a lot of state government information, data, Central Water Commission data, dam data, all that information they collect, and then what we do is we give an impact-based weather forecast for each subdivision, each district of the country, and that is valid for 5 days in advance. Once that job is done, then the 3-hourly nowcasting starts. So this is maybe the flow diagram, so to say, of the weather forecasting. This is where the video conferencing happens, the first step. When we come closer to the forecast period, that means in addition to the 5-day forecast, in the 1 to 2 day scale, we give more specific. Medium range means that we will give for a large part of a state. For a smaller part of the state, where the weather is likely to happen, that comes in the short range forecast. And when we come to the day of the weather, 3 hours in advance to the occurrence of weather, we issue nowcasts. So nowcast is something that has started maybe 2013, but it has really seen a lot of development in the last 3 to 4 years, as I told you, because of a lot of improvements and initiatives of the Ministry of Earth Sciences. So these nowcasts are sent to various stakeholders, whether it is state and national disaster managers, defense, aviation meteorology, power sector, cultural events or any social events, sports events, IMD website, media, all people are given the nowcast, which is a very location-specific forecast. So this is a general flow diagram for nowcasts, how we go around it every day, every 3 hours. This is done from the state level. And after using all the various current observations, not the model forecasts as much as the current information, we determine and which is the areas of weather, what will be the weather, and one thing Dr. Thirupugar talked about, one thing Honorable Minister Sir also talked about, impact-based weather forecast. So that is now coming in our bulletins. We not only give the warning, but also give an impact-based forecast and risk-based warning. That is given in terms of color and also, if possible, in terms of warning about what action to be taken for the weather. So I'll just show one small sample case of Bihar. It's a 2nd July case. So this was for 5 days the weather forecast was given, and after maybe based for 2nd July, on 1st July there was it was reflected in the station level from the meteorological center at Patna. They had issued medium range forecasts for this event at a district level, and maybe moderate to severe thunderstorms, that lightning would happen. That information was sent through press releases, through intimation to All India Radio, Doordarshan, private press, electronic media. They were broadcasted on 9 hours IST through popular radio channels, and then nowcast warnings. 23 nowcast warnings were issued for, this is the press release that was issued, this was the nowcast that was issued. So all these actions were taken in order to warn the state government, the state disaster management authority, the respective district collectors, the media. Every forum was used to transmit the information, and yet, as Dr. Thilukpukar sir said, we failed to prevent as much deaths as we would have preferred to do so. The 3 early nowcasting that is now coming on the IMD website, this is updated 3 early. You can please check it on the IMD website. This has been valid for the stations. We give particular stations, district headquarters, tourism and commercially important stations, as well as the districts of India, all the districts of India. These are in 19 categories, if you see. These give warnings not only for thunderstorms per se, but also weather associated with thunderstorms. So if you see the 0.6 or the 0.9 or the 0.18, you will note that cloud to ground lightning probability warnings are also issued. And if you see, this is a warning issued maybe 2 days back, maybe a few days back on 10th of July for Jamtara district. So this kind of warnings, along with the language, is given in the IMD website. This is in addition to the nowcasts that the stations are sending. These nowcasts that stations are sending are coming through SMS, WhatsApp, email, and this is the kind of language sometimes the states are giving in terms of local language. The respective warning, whether that will affect the action now. Okay, the action that is being taken. And another thing that we ought to also keep in mind is 3 hours for a district maybe is considered a bit too large, but we, through the Damini app, the Ministry of Earth Sciences is also giving 40-minute warnings, 30 to 40-minute warnings for a very specific region. This is a screen capture from my own mobile, so that is around Delhi it was taken. But this is giving very specific block, street, village level warnings for 40 minutes. So please use our warnings for the district when we are saying within 3 hours, this district is to be affected, along with these Damini app warnings, to get a more specific interpretation for the weather of your particular location. That is important. And this warning that we are sending, it's a manually generated warning in the local language as well. Our warnings are all on the public website. We verify our warnings. And if you see our thunderstorm forecast detection, for example, in the 24-hour scale, there has been I showed you the 3 stages. The second stage warning verification, it has improved, it is doubled in fact. We are detecting double the number of thunderstorms. False alarms is only 30%, 33%, so to say. And almost all the states, if you see, the blue colors indicate improvement, wherever there has been a substantial improvement in nowcasting, in the short range forecasting, has shown significant effect. If we consider the nowcast warning verification, we are at 0.85. So 85% of the nowcasts have been verified against observed thunderstorms, not against lightning, but thunderstorm reports. They have been verified, so we are quite good on that. Some false alarm is also high, but we have to improve. So that shows that every year a lot of improvement has to be done, and this is an all India effort. This is not a one person effort. The final things that I would like to talk to you about is, so research review. So we do review, training workshops. So participation in state government activities, pre-season exercise on our own behalf at the state meteorological centers to educate media, public, school children, college children, the general public, and then we take part in the activities of the state government to raise awareness of disaster risk and its management. Every state, every district does not have the same kind of weather, so customized information, customized awareness is necessary, which we take part. Third thing I'll come to first, then I'll come to the second. Post-event, post-season analysis. Anytime a major event happens, the very next day or within 2 or 3 days, we collect all the information we have sent through the state level, through the national level. We reanalyze where we went wrong or what we could have done to make it better. So that, and then the post-season analysis, we produce a report which is again available at the public forum to showcase where we are failing and where we are succeeding. So that is a constant process, and we collect feedback. This is where we need support of NDMA, support of the public media to give us information. Like I said, our observatories are not very close together, which we need the information to get and give it. 2 slides, because I wanted to address Dr. Sri Nityanand Rai sir's request for climate change. So, and aerosols. Generally, aerosols can have different impacts on lightning. Clean environments, adding aerosols enhances lightning activity. Coming to the Indian region per se, there is a very good paper by Kenki and Kamra from Indian Institute of Technology. Yes.
Running little short in time.
Okay, then I will finish this 2 slides. One is 26% higher and highly correlated with flash rate over Northwest India as compared to Northeast India. If we see climate change, there is an increase in the lightning activity. Cloud to ground lightning frequencies are increasing. Yes, especially over the foothills of Himalayas, there is an increasing trend in lightning activity in the last 20 years. So our warnings have to increase, be more specific, and give the we give the forecast in right time. So 5-day to 3-hour scales, we are giving forecasts, impact warnings. We hope it will be useful to all. Thank you.